Hey guys, in this session, we are going to learn about Docker. We're going to see why do we need Docker, what are the different challenges Docker solve. So let's get started. So let us understand why do we need Docker with an example. So typically, when a project comes, suppose you're working in an organization or you're working yourself. So typically, when a project comes in, so you can take an example of suppose you are building a e-commerce project. Okay. So if an architecture or tech lead has decided that, okay, this e-commerce project will be a single page application plus of microservices in the backend. Okay. So this is a typical example, typical architecture. I'm talking about very simple one so that we can understand the use of Docker and the why do we need Docker. Okay. So suppose we are building it with React in the front end and it talks to the backend services, backend microservices. You can take it as backend, and this backend is talking to the database, and this is normally the bare minimum architecture nowadays we build, right? Now, whether this backend consists of multiple services or a single services, here I'm taking an example of a single service backend which talks to a database. Here also, I'm not database can be of MySQL server anything, but just the context is important. So for this particular project, what how do we do what we do? So in the local machine, we set up we install React, we set up install the React binaries, etc., and then do the setup for the React. So we are primarily interested in the backend services. So we'll take a look into that. So for the backend, you choose the language. Suppose here I'm taking an example of Java, but it can be applicable for .NET and Python, etc. Okay, Python Go. So in the backend service, what we normally do, we first install the JDK and all. If I'm taking an example of Java, we first install JDK, then IDE, and then finally we do the development. Okay. So during this development, we say that okay, this backend service needs to talk to the database. So what we do, we also install the database, but the installation is happening on the bare metal. Okay, bare metal means like you directly download, you Google it, you download the software, you install it. It basically install it into your operating system. Okay, it installs in your system directly. So it copies the files directly into your operating system. Okay, so suppose you are installing some version. Suppose you are installing MySQL version 8. Okay, and here, okay, this MySQL Server 8 into your system. Now you do the development. Once you are done with the development, you create a jar. Now finally, to run the application, you run this application like you run this application with the help of the command. Ultimately, that runs on top of the JVM. Okay, so JVM is needed to run this jar. So this is the typical approach, and plus we need to have MySQL server running in your local machine. Okay, MySQL server is running on your local machine. Then only this entire application will talk to the MySQL server, and whatever is the intention of this application, we are able to run it. Now, then let us understand the scenario. Once you are done with the development, initial setup is done by the tech lead, etc. He will push the code into the GitHub with this backend service. Code will be pushed up into the GitHub, whatever the Bitbucket. I'm talking about CVS. Okay, any version control system. This code is pushed. Okay. Now suppose a new team member joins into your project. The same setup needs to be built. Correct. Needs to be set up in his machine. So what he does, he simply checked out the code into his machine, and then again what he says, hey, in this readme file MySQL server is mentioned that needs to be installed. So what he is going to do, is going to install the MySQL server on his machine. Now it could happen that that particular team member, the team member who joins this project, may be coming from a different project, or maybe using maybe using the different version of MySQL in his local machine. Suppose he is already having MySQL version 5 in his machine. Okay, and but the requirement of this project is to have MySQL version 8 in his machine. So in that case, what is the final outcome? Either he uninstall the MySQL 5 and install MySQL 8, but it could happen that parallelly he is doing some stuff or something is really dependent on this MySQL 5. So what is the requirement here? So he has to install two versions of MySQL, or he may end up corrupting his machine by uninstalling the first and installing the second MySQL basically. So this is one of an example where MySQL server is taken as a dependency. So this is a dependency for this service. Okay. So this is the smallest of an architecture. It could happen that this backend service needs to talk to Redis. This backend service needs to talk to another backend service, right? So what would happen? That in that case, the Redis needs to be installed. In that case, this backend service needs to run on into his machine. So if that is a team of more than 4 or 5 members, then every member of this team is going to do the same stuff, correct? And they end up having multiple versions of the same software installed into his system. So this is a problem into the development environment where every other team member is going to install the softwares into his local machine without and causing the system to have multiple versions and end up causing issue, right? So this is one of the problem statement that is solved by Docker, where we do not have to install the softwares into the local machine directly. We can install the Docker into the machine and then install, then run the Docker images, basically Docker images for MySQL, Docker images for Redis. So in this way, these all things, Redis, MySQL, all these dependencies, the dependent softwares will not install directly into the operating system. They will install via Docker, but within the Docker. Basically, they runs as a Docker container, and we'll talk about it. What is Docker container? What is the Docker architecture, etc. So the bare thing is that previously we install softwares directly. Okay, here we directly install the softwares into the operating system. Now with the help of Docker, what would happen? We have a Docker layer. Okay, you can think of it as a one more software layer. We install Docker first, and then we run Docker containers on top of it. Okay, so if you see here you see we are not installing the softwares on the operating system. We are running the softwares as Docker containers onto the Docker layer. We are simply running it. We are not installing it on the operating system. So this way we can run multiple versions of the same software with the help of Docker without even installing it into the operating system. So your operating system is really safe. Means you do not have to worry about installing, uninstalling from the operating system, polluting your operating system. And it also like it's up to us, like which version of dependency needs to be installed, or we just have to run those with the help of Docker. So that way it is more of one abstraction layer on top of operating system, where it talks to operating system, it makes use of the operating system, it makes use of the underlying hardware resources, RAM, memory, storage, etc. But it is not installing directly into the operating system. So that is the advantage of Docker. Okay, so don't have to install anything on the operating system directly. It's an abstraction on top of operating system. So this is the example from the development perspective. Now, also primarily running the completed application into the system. So this is one thing. Secondly, if I talk about, if I say, let me just create a new document. Okay. So secondly is from the running perspective, running applications. Okay. So running application basically means like this is one example where jar is running on top of JVM, which has some configurations. Okay. So we will have some configurations, etc. So what we does, we bundle this up, the entire thing. Previously, what we are doing, we are creating a jar, installing the JVM into our operating system. Basically, what we are doing, we were doing it previously. We were installing JVM on top of operating system. Then we are running the application on top of it. Okay. So this we were doing, but when Docker come, okay, with the help of Docker, with Docker, what we are doing, operating system, we have a Docker layer. Okay. On this Docker layer, we are having this JVM and app combination running as a container. So this runs as a container. Okay. So on this Docker layer, basically this is Docker engine basically. Okay. So on this layer, Docker engine, we can run more than one container. So one container for JVM and app combination, one container for Redis, one container for MySQL. So all these are running as a container on top of the Docker engine. Okay. So this is the bundle of it, like app, JVM, jar, all this thing is termed as the bundle, basically is termed as Docker image. So you can think of it as a Docker image as a another package format. Like we have jar, we have DLL, etc. So Docker image itself is a package format. It bundle up things. It bundles the runtime basically on which is needed to run the application. It bundle the application itself. Okay. It bundle the configurations. Okay. So this is a Docker image. So when I say Docker image, typical Docker image looks like for Java applications. Okay. Now similarly for .NET, how it looks, we have a .NET runtime. Okay. Then we have DLL. Then we have configuration. So this is Docker image for .NET app. Okay. Docker image for .NET app. Similarly, we have a Docker image for Redis. Okay. Config. So the Docker image is a package. This is a package which contains the runtime, which contains the application, which contains the configuration. Okay. And this Docker image. So what we do, we first create a Docker image. We host the Docker image. Host means like we do host, like we have node modules that is hosted on the npm registry, right? We do host artifacts, jar files into the artifactory. Similarly, the Docker images are also files itself, right? So they are going to be stored into some servers. So if we have a public server, then that particular public server is nothing but we normally say Docker host, Docker hub. Okay. So Docker hub is a public registry to host Docker images. Okay. And we can also have our own server running in, like the company, every company can run their own server to host Docker images. So then in that case, it will be a private Docker registry. Like we have in AWS, we have ECR, like we have Elastic Container Registry. Then in Azure, we have ACR, Azure Container Registry, Google Container Registry, right, in GCP. So all these are what they are hosting the Docker images. And then what happens, this Docker image are when run is termed as running Docker image is termed as container. Okay. So that way, what we are doing, we are installing the Docker, we are running the Docker engine, and this Docker engine is running on top of operating system, and on top of it, containers are getting executed. So that way, what is the advantage of Docker in that case? So we do not have to install directly into the operating system anything. We just have to download, install the Docker into the local machine or into any environment, and then we have to run the Docker containers, and then in that manner the application spin up as a Docker container. They talk to each other, and the end product, the backend service, will go up, right? So what is the advantage of Docker in that case? So Docker gives isolated processes. Okay. Second, no need to install directly into the operating system any of the packages like Redis, MySQL, etc. We don't have to install directly into the operating system. So this is really helpful, and also security is baked in the form of a Docker container, like because it is a package which contains the runtime, etc. So we can have a secured images within it, basically properly sanitized and you can say hardened images we can use within that box. So yeah, and they ultimately using the underlying hardware resources, RAM, so we can control the resources that Docker containers needs. So there is a control mechanism by which we can say that, okay, this particular Docker container can get only this much memory or CPU, and this particular Docker container can get this much memory and CPU. So resource management can also be possible with the help of Docker. So this is what the benefit of Docker. You create the application. So whenever you create the application, if you want to run those application, just create the Docker image of your application, which will bundle the JVM within it or runtime within it. It could be a Python runtime or .NET runtime basis on your application. If you are building a Java application, so you have to bundle the JVM. If you are building up the Python application, you have to build up the Python runtime. So you create the application, you develop the application, you create the Docker image, then you host the Docker image into the Docker registry, then you run the Docker image as a container into the Docker engine, and finally the Docker container talk to each other and the application got up and running. And the benefit of it is that you just have to host that Docker image into somewhere. The other person who want to run the same application onto his machine, he just have to install the Docker in his system and he can run those applications. Or the same Docker image, we can put it into the EC2 machine or AWS virtual machines or GCP virtual machine or Azure virtual machines, and we can simply run those Docker images directly into those machines. We do not have to worry about, okay, like this software, this runtime. Previously, like we need to communicate this stuff to the server administrator. Okay, this is the application I built up, which require this runtime, which require this version of Redis or this version of MySQL. We had to communicate to the server administrator. So server administrator has to check the list. Okay, this is the version. Okay, I need to install this software to run this application. Okay, let me do that. Okay, and they come up with the challenges where they have to uninstall and install different versions of the same software. So, but with the help of Docker, they don't have to worry about it. They simply have to first of all, everything is automated, but if manually has to be done, they simply has to take down the image of the Docker and run it, because the image itself contains the runtime. So there is no need to worry about which runtime to run, which version of runtime to run, or which version of the software I need to run or install. So everything is taken care of with the help of Docker. So yeah, so in this session we covered up the basic concepts of Docker. Why do we need Docker? What is the challenges that Docker solve? And in another session we are going to talk about architecture of Docker in more depth, like all this terminology, etc. So little more streamlined manner, and then obviously we are going to cover up the practical examples with the help of commands, Docker commands, etc. Hope you understand this session. If you like this video and if you do not want to miss any upcoming videos in this session, so do subscribe this channel and stay tuned. Thank you so much. Bye bye.